A deep dive into blockchain scalability. Today, Bitcoin is operating at a fraction of its potential. Transactions take hours to confirm, and the network can only handle about 7 transactions per second. Ethereum fares better, but it still needs to be able to support widespread adoption. One proposed solution is called sharding. It would divide the blockchain into sections that can each process transactions in parallel, speeding up processing time and reducing blockchain bloat, the size of its data set, which could make it more affordable for people with limited bandwidth or computing power to use cryptocurrency networks. Blockchain scalability, which mostly refers to transaction speed, is often considered both the holy grail and the bottleneck of the cryptocurrency industry. The time it takes to complete a cryptocurrency transaction currently cannot be compared to that of conventional payment methods. However, crypto communities are working under various hypotheses on how to overcome this obstacle. This post delves deep into the intriguing breakthroughs that might lead us to near-instant transaction speed. But before we look into various scalability methods to speed things up, let's first take a deeper dive into the fundamentals of transaction speed. What is transaction speed? Transaction speed refers to the time it takes for a cryptocurrency network to process a transaction. It's often overlooked because transactions like sending Bitcoin or Ethereum can be drawn on a timeline. Still, transactions are spread out over various connections between the cryptocurrency network and its participants. This makes it difficult to measure exact speeds due to these varied connections between networks, though most users expect transactions to happen faster. Some limitations imposed by the underlying technology of cryptocurrencies themselves will influence transaction speeds. The main limiting factor of transaction speed is the processing capacity of the main blockchain that hosts the cryptocurrency. This is because every participant in a blockchain must store and process all data that occurs in the blockchain. Therefore, processing data on such a large amount of data will take longer, but it's shorter than most people think. The second factor is the speed at which participants can send transactions to each other. Today, it takes several minutes to send an Ethereum transaction, and you'll see the same thing with Bitcoin. These delays are caused by sending a transaction through the underlying technology, such as broadcasting it on the blockchain. The trade-off is that transaction speeds depend on how fast you can process your data, which is why a hardware wallet reduces this delay. The blockchain scalability trilemma. To further complicate the matter, we realized that transaction speeds are not evenly spread across all cryptocurrencies and blockchain networks. Instead, they can be categorized into 3 categories. Fast, newer cryptocurrency networks, such as Bitcoin and Ethereum, allow transactions from seconds to minutes. Slow, older cryptocurrency networks, such as Litecoin and Scash, allow only a few transactions per second, which means these blockchain platforms cannot be used for instant payments or micropayments. Decentralization. The third category is the one in which cryptocurrency communities focus on decentralization. This type of scalability is the most worthy of discussion because it's not just a feature but an essential part of its overall purpose. Blockchain technology aims to create a fully decentralized platform, allowing each participant to run their node. Security. The capacity of the blockchain to withstand invasions from external sources and the system's resistance to manipulation are the 2 components that make up its security. A blockchain network is susceptible to a wide variety of attacks, including double spending, Sybil attacks, distributed denial of service attacks, and 51% attacks. Greater decentralization can be achieved with greater freedom, such as free entry and exit from the network. However, this comes at the expense of decreased security because it is difficult to confirm the identity of new players. These new players could be under the control of a single malicious entity or could be working together to disrupt the network. Scalability. The fourth and last category is scalability. The ability to be increased over time to accommodate user growth. To address the scalability problem, many cryptocurrencies use pre-mined coins, such as Bitcoin, which are created from nothing and dropped into users' wallets, which can be used immediately. This creates an immediate demand for more miners to mine coins and process transactions, making their distribution more rapid and the price of these coins more volatile. To make things even more complicated, there is no one way of achieving faster transaction speeds on a blockchain network. Blockchain networks can be divided into two groups, permissioned and permissionless ones. Permissioned blockchains. Permissioned blockchains have a group of trusted nodes that can be accessed by authorized users who have been approved to access special features of the blockchain. The only way to join these nodes is via an invitation from the owner. Although this approach helps ensure transactions are processed, this also means that the network can be influenced by a single person who can gain access to the blockchain's consensus mechanism. Existing and future approaches to scalability. When attempting to find a solution to the concerns around the scalability of blockchains, there are a variety of other issues that crop up. If, for example, the solution can only be implemented on a single blockchain, then the effort is either unneeded or oriented in the wrong direction unless it is expected that the particular blockchain in question would someday require blockchain scalability. Another important consideration is becoming familiar with the prospective costs and benefits. Every choice that is now available comes with certain restrictions. For example, the permissionless blockchain approach does not restrict who may join or leave. This conclusion is consistent with a related conclusion that has been reached as to where blockchain technology might be headed in the future. If membership of permissioned blockchain networks continues to increase at its current rate, it appears that some massive scalability event will take place, possibly accompanied by the appearance of a single, monopolistic entity. Batch payments into one transaction. One of the first attempts to address this problem involved the creation of a second layer, called the Lightning Network. This is not a blockchain network, but rather an overlay on top of one built from a series of payment channels. Payment channels are just like blockchain networks, only they can process much faster because they do not have to be confirmed on the main blockchain. Bitcoin Cash. Bitcoin Cash is a new approach that relies on increasing the amount of data stored in each block, the same data stored in the blockchain. Since each block cannot hold more than 1 megabyte of information, this approach decreases confirmation times because not all transactions need to be confirmed by a miner. Bitcoin Cash's approach also reduces financial incentives for malicious actors by requiring participants to pay a small number of their transaction fees when mining blocks. The Lightning Network. The Lightning Network transactions among parties take place immediately, without fees, off-chain. They are only possible on blockchains built on the Bitcoin core if users have Thunderbolt nodes. These transactions are only possible on blockchains constructed on the Bitcoin core. The Lightning Network is a mechanism for conducting off-chain transactions exclusive to Bitcoin and accessible for Bitcoin and blockchains that have been forked from Bitcoin, such as Digibyte and Litecoin. It allows you to remove your Bitcoins from the blockchain and conduct a transaction with another party in complete privacy. The benefit that it provides is instant transactions that do not incur fees, which enables users to make immediate purchases of smaller items, such as a cup of coffee, without incurring further costs. BLO's route. Because it is an on-chain solution that is not specific to any one blockchain, it is scalable for use with any blockchain. Although it is still being developed, the blockchain industry must finish the challenging and expensive task of developing and maintaining a worldwide CDN. Outside of blockchain-specific projects, the formation of startups to address the problem on a larger scale. BLO's route is proposing to superimpose a content delivery network, often known as a CDN, on top of blockchain networks to solve scalability problems. Conclusion. The idea is to increase the speed of blockchain networks, allowing them to accommodate more transactions. Implementing a CDN on top of blockchain networks requires the same approach used for years in conventional IT environments. While it is true that BLO's root technology does not address the problem directly, it does provide an answer to scalability in a way that will work with any blockchain and cryptocurrency, i.e., XRP. BLO's root can be implemented using a Lightning Network approach or simply through a full node. Regardless, BLO's root is the best outlet to address scalability while providing the features and speed that will make it possible to achieve mainstream adoption.